Hello everybody, welcome back to another Graphing Calculator Showcase episode. This is the 1.2 update. Very exciting. It's not that exciting, but it's kind of exciting. Actually, it's pretty cool. I'll stop talking now. So there are 6 new blocks, 2 new coordinate systems, and a couple GUI improvements. That's the main thing of it. And then there's also one more thing that I'll get to in a minute, and that's the aggressive discontinuity threshold, which is a new setting inside the GUI. And like I said, I'll talk about what that does and how to use it in a minute. Recipes for the 2 new coordinate systems are these 2 blocks here, or items. I've continued with my trend of pseudo-randomly generated nonsense items. No, they do have very little rhyme and reason behind them, but there is some. Anyway, the 2 new coordinate systems are the Parabolic and the Prolate Spheroidal, which of course was inevitable after the Oblate Spheroidal. And you can switch between them, of course, the same way as you can with all the other ones. So, onto the GUI improvements, because I'll let you play around with those on your own if you're interested. Actually, this is this is the showcase video for not only the 1.2 update, but also the 1.1 update, I suppose, because I haven't put out one for the 1.1 explicitly. So, we have GUI blocks, very cool stuff, and the 1.2 update, the 1.1 update added the blocks, the 1.2 update has added the little text tooltips down here, and also the nicer number formatting up here. You might notice a lack of several digits. It no longer prints the entire double, nor does it print the decimal place if it's just 0.0, so that's much nicer to deal with. You can see the numbers look significantly better than the previous update. And of course that is not the case over here with copy-paste values, because you want all the numbers there. Like yeah. There you go. Anyway, so onto the blocks, the actual showcase of them. We have several pages, or in this case 2. It depends on your screen size, how many pages, of course. And if you hover over one, it'll tell you exactly what that thing does. And you can drag a block down and set your equation with them. So let's do x plus z. This is Cartesian, right? Indeed it is. Alright. And you can delete a block by dropping it in this little red square. Okay, so let's do x plus z. We want value plus value, and x or z plus x or z. And there we have it. So that's much nicer to deal with than this string up here, which was the previous way of doing things. Good times. So yeah, we can now stack these as much as we possibly want. We can pile in like a bunch of logs in a log cabin. You click on it to drag it out of the little sideboard, and you can click it to drop it again. You can pull them out of the nested blocks, and works nicely. And we've got whatever I built there. Oh yeah, I almost forgot to mention how you actually input values. So you type the value you want to input up in this little box here, and then you hold Shift and click on the value block you want to add that to. That way you can still click it and move it, but when you want to add a value, it's pretty easy to do it to a bunch of them. Like for example, not you, negative square. Like for example, there. And with this box, by the way, you can also input various values that I have hard-coded in, like pi or e or the golden ratio. I'm not sure how useful some of these ones are, but they're listed in this text box. And for example, I can put pi in, press that, and I'd wager that's about 3.14159.265 blocks up from the center of that calculator right there. Just a rough estimate, I'd say. And likewise, 2.7182818 blocks up from the calculator there. And you get the idea there. So actually, I think if I where is it? Come on, you're spoiling the video block. I can't find you. Okay, this is getting ridiculous. There we go. That should be ln. Yeah. Demonstration right there. if you're not sure, if you don't know what I did there, the natural log of e is 1. Likewise, the Bates 10 log of 10 is 1. Anyway, that's beside the point though. I'm getting distracted. The different things here are randomized. The colors are randomized, that is. So you might not get the same colors every time, but at least they'll be different, so you can see where one block ends and the other block starts. I haven't actually hard-coded any values for them yet, but I might do that because that way it would increase the consistency and the ability to identify a block by its color. Also, I am going to keep this this text box, because if you don't want to copy all this stuff here by using a graphing calculator or memory card, then you can just copy the function by copying the string, right? So it does have some utility, so I'll keep it in there. One more thing, these values here can be, or sorry, the number of decimal places displayed can be changed via the config. So keep that in mind if you want to show fewer digits or more digits. That's a possibility. So then, onto this mysterious aggressive discontinuity threshold then. Well, to demonstrate what this does, I'm going to take a look at our Bipolar Cylindrical 3D graphing calculator. And if you've used this one before, you might already be aware that it can be a little bit fickle trying to get something that looks nice out of it. So let's see, we've got sigma and tau, huh? Okay. So let's try tau. And yeah, that looks about right. But as I said, it's pretty messy, and that generally does end up happening with the bipolar cylindrical, which is why it's a good demonstration for this new feature. So let's up the resolution and tile count, and indeed, sails off to infinity over there, or close to. Okay, maybe not that close, but pretty far. Anyway, so let's restrict the domain a little bit, because that's what you do with the bipolar. But oh, whoops, not quite that much. I can't remember. Is it? Yeah, I think it's something like that. All right, so we've pretty well trimmed the range, the domain there, right? But it still goes off way over there and way over there. So this is where the new setting comes in. When you don't want something to be moving so quickly out on the edges, or in general perhaps, this value right here is your friend. So that's the aggressive discontinuity threshold to the right of the normal discontinuity threshold. So let's pop this up to 2 and see how that changes the graph. Not bad, not bad. So what it's doing is any tiles that grow to be more than the aggressive discontinuity threshold are trimmed off. And what that ends up doing is trimming those giant planes that we don't really care about, and it makes the bipolar cylindrical graph in particular look a lot better, since it doesn't show us a lot of meaningless garbage. This is especially helpful in regards to, for example, this graph. Let's see, and it's especially helpful when you start going for larger domains, because as soon as you start doing this, you no longer can. Sorry, 0.28. That would be a large number of things. Anyway, once you start doing these larger domains to see the cool stair step, for example, you can't trim off these central bits where it gets really large over in the negative whatever directions. You can't trim them off because you want that in your domain. You just don't want the ugly parts. So this allows you to trim off those bits, and it's pretty helpful there. Now if we untrim those, you can see the graph looks significantly worse, and indeed you can't even see part of it right here. So all in all, I like the change, at least, even if no one else does. Yeah, there we go. Now, just as a clarification, the normal discontinuity threshold clips blocks that exceed the given slope, and the aggressive discontinuity threshold clips blocks that exceed the distance. So the distance can be in Cartesian x, y, or z, whereas the slope only applies to the rate of change of the function itself. So that's not related to the Cartesian values, and so it sometimes misses things that maybe you would like not there. Lastly but not leastly, in the 1.2.1 bug fix sort of minor patch update, I have altered the lighting a little. So if you look back in the previous clip and then in this one, the lighting is much better, and that's because previously it was balanced around moody because I didn't realize that was what things were set to in the Eclipse testing environment. And now, since I play on bright, I realized that it was completely bleached in one color, no shading at all when you play on bright. So I've rebalanced the lighting a little. Should be better. And I've also taken the liberty of adding a couple new blocks, which are probably best shown on the Cartesian calculator. Let's take a look at them. So we have natural log there, that was already there, and what I've added is positive natural log, preserved natural log, positive base 10 log, and preserved base 10 log. And those correspond similarly to the positive square root and preserved square root and things like that. So if you already know what those do, then you probably know what this is going to look like. Let's take a look at natural log of x, or z because I missed the key. Looks about right? And let's up the resolution just to see it better. I end up doing that an awful lot. Maybe I should change the default. Anyway, that's natural log of z, right? However, its domain is restricted, so that's the difference between the other two. Positive natural log, there you go. And the preserved natural log is sort of the same, except flipped over. Did I mess something up there? Oh, yep. I took the exact same block out. Nice. There's the preserved. Okay. And the same goes for the base 10 log, so I'll just do the preserved, and you can infer the rest. There you go. And that will be it for this update patch video. So hopefully you enjoyed it, and I will see you in the next one. Take care, and bye-bye.